Hello everyone, my name is Abhishek and welcome back to my channel. So as promised, today's video is going to be on Kubernetes operators, and this is going to be a end-to-end video on Kubernetes operators. Now, what do I mean by that? So in this video, I'll not just explain you theoretical part of the Kubernetes operator, but we will also gain practical understanding of Kubernetes operators. So if you watch the video till the end, you will get a very good knowledge of how to write Kubernetes operators. So this is what we are going to cover today. And as part of the video, of course, in the theory part, I'll explain you what is a Kubernetes operator. I'll tell you why to use Kubernetes operator. We'll try to compare Kubernetes operators with Helm package manager, try to understand how they are different from one another. Then we will see what are the different types of operators. Like in the market, you have Go based operator, you have Ansible based operator, you have Helm based operator. So what are the difference between each of them and which one is better than the other two? Then we'll explore the popular operator framework, using which we'll try to write the Kubernetes operator. This operator framework is very important because let's say you have little experience on Go language, or if you're afraid of using Go language, using the framework that I'm going to cover today, you can easily write the Kubernetes operators even if you don't have expert level idea on Go language. And after that, we will proceed with the live demo where I will cover the part that is how to write Kubernetes operator. Of course, when we talk about each of these things, we'll cover a lot of other things as well, like the architecture of the operator. We'll try to understand the difference between a Kubernetes controller and an operator. We'll try to talk about operator lifecycle manager. So a lot of things will be covered as part of the video. And you might have understood by now that it's going to be a lengthy video. So without wasting any time, I'll quickly jump onto the video and start explaining what is a Kubernetes operator. So to understand what is a Kubernetes operator, you should know what is a Kubernetes controller. Like, I'm not going into the details of Kubernetes controller here because I've already explained what is a Kubernetes controller. If you want to understand custom resource definition, Kubernetes controllers in detail, then please watch the video using the link in the description or in my Kubernetes playlist. But for the purpose of video, a Kubernetes controller is something which is basically used to manage a state of particular Kubernetes resource. For example, a very simple example is you have replica set controller, right? What does this replica set controller do? It maintains the state of your Kubernetes pod. So it just not just installs your Kubernetes pod, but it always ensures that the number of pod or the number of replicas of your pod are always matching the given state. So there is a sync between the expected state and the real state. I mean the actual state on your Kubernetes cluster. That is your Kubernetes controller. So there are native Kubernetes controllers like your replica set controller. But apart from this, there is something called as your custom Kubernetes controllers. Okay. So some example of custom controllers can be the ones that we use very frequently. For example, Nginx ingress controller is a custom Kubernetes controller. Argo CD is a custom Kubernetes controller. Istio is a custom Kubernetes controller. Then you have a lot of other things like, for example, you have Kyverno, which is a custom Kubernetes controller. You have KubeHunter, multiple Kubernetes controller. Of course, there are thousands of custom Kubernetes controllers in the market. Why do you write this custom Kubernetes controller? Whenever you want to extend the capabilities of the Kubernetes cluster that are not provided by Kubernetes out of the box, right? For example, Istio Kubernetes controller. It solves the problem of mutual TLS that is not available in the Kubernetes cluster. So the people at Istio, they have designed a custom resource definition. They have created a Istio Kubernetes controller. Now it's up to the users to create the custom resource, and controller will act upon the thing and it will perform a specific action. So this is about the controllers and custom Kubernetes controllers. So end of the day, there are some kind of deployments or custom Kubernetes controllers or some kind of stateful sets which you deploy on your Kubernetes cluster to perform a specific action to extend the capabilities of your Kubernetes cluster. Now, that's not the topic for today. Our topic for today is the Kubernetes operators. Now, Kubernetes operators are something which are used to bundle, package, and manage your Kubernetes controllers. Okay. So what is a Kubernetes operator? A Kubernetes operator is something that is used to bundle, package, and manage your Kubernetes controllers. Most likely, we will deal with the custom Kubernetes controllers itself. That means we use operators. If we take example of Istio in this case, okay. So if someone is writing a Kubernetes operator for Istio, the purpose of the Istio operator should be to bundle the entire Istio related resources, to package the Istio related resources, and to manage the Istio related resources. That means it can be your Istio deployment, Istio config maps, secrets, everything will be bundled, and then they will be packaged and managed using the Kubernetes operators. Now you might ask me that what is the purpose of using Kubernetes operators here? If I have a Kubernetes cluster with me, let's say this is a Kubernetes cluster, and if I want to install Istio on top of it, if I want to install Istio Kubernetes controller on my Kubernetes cluster, I can do it using plain YAML manifest, right? I can just go to Istio documentation, find the plain YAML manifest, or if I'm not interested in the plain YAML manifest, there is also Helm charts, right? I can use the Helm charts to install Istio. Very correct. You can either use YAML manifest or you can either also use Helm charts. But I am going to introduce you one more mechanism today, that is using the Kubernetes operators. So what is the difference between using Helm charts versus using operators? Okay, so let's say I use operator here and I use the Helm chart here. Both of these things, like Istio has an operator and Istio also has Helm chart. Okay, so that's why I took example of Istio. Like you can take any other example, but the only reason why I've chosen Istio is it has an operator and it also has a Helm chart. So you can install Istio using Helm chart and you can also install Istio using operator. But what is the advantage that you gain by using operator? Firstly, let's talk about Helm charts. What Istio Helm chart has on a high level is, it has a chart.yaml, it has something called as values.yaml, and all the required files, resource files, that can be your Kubernetes deployment for Istio, config maps, service, secrets, etc., etc. So everything is present in the Helm chart. And when you install this Helm chart, all of these resources, if there are any fields in the values.yaml, they would get replaced and they would get installed on the cluster, right? Let's say there are 10 resources here, for example, okay, including the config map, secrets, deployments, and everything. The Helm chart will take care of updating these resources if there is anything that is required from the values.yaml with the proper fields. Let's say you want to install this Helm chart on dev, and then you have certain fields for developer environment. These fields would get updated from the values.yaml to the deployment config map wherever it is required. And these resources are deployed onto your Kubernetes cluster. Now everything is fine. Helm is doing wonderful here. But let's say someone comes to your Kubernetes cluster and modifies the deployment.yaml with like someone updates the port of your deployment to a wrong port. Or let's say someone updates the service with the wrong host name. Anything, right? Or someone mess up with the secrets, or someone mess up with the config maps. Helm does not have the capability to override these changes because these are wrong changes, but Helm controller cannot look into these changes and update the changes. So there is no way of fixing these things. So this in Kubernetes is called as reconciliation. Okay, so if you are using Helm charts, this is only one thing. I'm going to talk about the other things as well. So the first thing is Helm charts cannot reconcile to the actual changes. If someone installs the resources of Istio using Helm charts, they can install it very well, but they cannot do the reconciliation, or they cannot fix the things that are updated by someone. Okay, now why does this happen? This will happen for multiple reasons. Why would someone update the service? Why would someone update the deployment? That's a different discussion. But Helm does not have a reconciliation. Whereas if you are using the operator also does the same thing, but the package structure is different. Like in operator, you don't have charts, you don't have values. We'll discuss about the operator structure later. But if you are using an operator, consider that there is a bundle. Okay. So I'll explain the structure of bundle. Like you people know the structure of Helm chart. In operator, there is a different structure, which we'll talk later. But you know what operator does is when you try to install this operator, it would install the bundle, and bundle will again install the resources that we have mentioned here. Okay. So let's say this is a Go based operator. So you have written the entire operator in Go language. And when you install it, the bundle would create the exact resources that we have mentioned here, the deployment, service, config map. If there are 10 resources using Helm chart, technically there will be also 10 resources that will be created by this operator. And the advantage is that if someone goes here and updates the YAML manifest with some wrong details, operator says that no, I'm continuously watching if there is any change. So apart from bundling, packaging, managing, what operator does is it will also override any wrong changes. So how does it do? I mean, how it does it? In operator, whenever someone is writing a Kubernetes operator, they write a reconciliation logic inside the operator. Now, this reconciliation logic is responsible for auto fixing the modifications that are made by the users. Now, who writes this reconciliation logic? Whoever writes the operator writes the reconciliation logic. If they miss to write it, then yeah, definitely your operator will fail to do it, and it's a issue with the operator. Okay. So probably if you're using Istio operator, then you can go and raise the issue in the Istio operator, which is an open source project. Okay. So this is one thing that operator offers you on top of Helm charts. Apart from that, let's say there is a new version. Again, we'll take the same example here. Here you have Helm, and here you have operator. And the second comparison that I'm going to bring here is the upgrades. Let's say there is a new version of your controller. Again, let's take the example of Istio here. Let's say there is a new version of Istio. Today, let's say the version is x.y.1, and tomorrow there is a new version that got released called x.y.2. And this x.y.2 is handling some critical vulnerabilities, and you have to update this at any cost. You cannot skip it, for example. So if you are installing operator, sorry for saying operator again, but if you are installing Istio using Helm charts, then it is your responsibility to go ahead and create new version of Helm chart. If there is new version of Helm chart already, what you need to do is you need to take the new version of the Helm chart and you need to deploy the new version of Helm chart. Only then the new version is picked up and your critical vulnerabilities are automatically addressed. Sorry. Whereas if you are using the operator, and if you enable the automatic sync or automatic upgrade option in the operator, automatically, I mean, operator also provides you manual, but let's say your upgrade policy is automatic in the operator, then what happens is whenever there is a new version released, then operator would automatically install the new version. Okay. So that operator also handles the upgrades of your, okay. So operator automatically handles the upgrades of your Kubernetes controller, which Helm does not offer. Apart from this, there are multiple other things, but these are the two primary things. One is reconciliation that your operator can take care of, which can also be called as auto healing. Okay. So Kubernetes operators perform the auto healing of your Kubernetes controllers when someone modifies it, if you install the controller using the operator. And the second thing it does is the automatic upgrades. And third thing it does is, these are the other things that I'm explaining. If you have one single operator, you can create multiple instances of these controllers. Like using one single operator, you can install the Istio controller even in 100 namespaces or 1000 namespaces, whatever you would like to. Apart from this, Kubernetes operators offers you some it can provide you some telemetry related information. Telemetry is nothing but it can provide you insights on who is using this Kubernetes controller, how many people have installed the Kubernetes operator, are there any issues. So these kind of information you can fetch if you install a controller using operator. So there is an inbuilt telemetry system that you can use. Of course, you have to enable it. And apart from this, your operator offers you a lot of other interesting aspects as well. So that's the difference between operator and Helm chart. I hope this is clear now. What is the difference between controller and an operator? And what is the difference between Kubernetes operator and Helm chart? So one thing what we have learned till now is a Kubernetes operator is something that essentially takes care of bundling, packaging, and managing your Kubernetes controllers, right? Bundling, packaging, and managing the Kubernetes controllers. And of course, apart from this, like I told you, it can also do automatic upgrades, auto healing, and all of the other things. And we have also understood the difference between Helm and operator. Now we will move to the next part. That is, now we have discussed things about the operator, but how do I write this operator? So I'm going to explain you this by sharing my screen as well. But right now, when I'm covering the theory part, I'll explain here. That is, if you want to write the Kubernetes operator, one thing is you can go to a portal called Operator Framework. Okay, there is every information that is available in the portal. It's a very well explained portal where you get to understand about operators. But to write operators, there are three different ways. Like for example, if you write your application, there are multiple programming languages, right? Similarly, if you want to write operator, you can write the operator in three different ways. One is you can use Go language for writing Go based operators. You can use Ansible for writing Ansible based operators. That means you can use Ansible as a medium to write the operators, or you can also use something called as Helm. So these are the three things. One is Go based operator, Ansible based operator, and Helm based operator. Out of all of these things, Go based operator is the one that you have to use. Like if you are not aware of Go programming, or if you don't know, if you don't have expertise on the programming languages, then you can choose Ansible based operator or Helm based operator. But if you are using these things, then you will not get all the features that Go operator supports. For example, if you are using Helm, then you might not get features like auto upgrades whenever like I told you, one of the good advantages of operators is if you are using operator, you can perform auto upgrades. If you are using Helm, you might not yeah, I think you will not get the auto upgrades. Similarly, if you are using Ansible, you will not get all the features. Whereas if you are using Go based operators, you can get all the features that operator supports. Okay, so there are different levels. So Helm, Ansible, and finally the top level or the complete features are supported by Go based operator. We can look about these details in the portal as well, where in the portal it is very clearly explained what is the difference between Go based operator, Ansible based operator, and Helm based operator. But one thing to mention here is if you are using Go based operator, then you can avail the complete features of operator. Whereas if you are using Ansible and Helm, you will not get all the features. For example, if you are using Ansible or Helm, you will not get the telemetry related information, because they are level 1, level 2 operators. Whereas Go based operators are level 3, level 4 operators. So you can get auto upgrades, you can get telemetry related information, you can get events, metrics. So all of these things are possible using Go based operators. So the next thing that I want to explain, once you understood the different types of operators, of course, I explained that Go based operators are better than the other things. Now, what are some of the popular operators? So one thing is operators are relatively new. Like many people might have heard about operators, but very less people have the expertise of writing the Kubernetes operators, or many people did not realize the need of writing the Kubernetes operators, and of late people have started writing the Kubernetes operators. Now there are some very complex controllers, like for example Prometheus. So Prometheus has a lot of resources. So one biggest advantage using operators that I told you is whenever there are multiple resources, you lose a track. Like for example, you installed Prometheus using Helm. It created some 10, 15 resources. It created Prometheus deployment. It created some config maps related to Prometheus roles and role bindings. And when someone modifies it, it is very difficult to track. It is very difficult to debug what went wrong in your Prometheus controller. So in such cases, it is better to use operators, and Prometheus operator is one of the very popular one. So I think it has the most number of stars for any operator, as far as I know, on GitHub. And then you have Elasticsearch operator, which is also very popular. Istio operator is also a very popular operator. Then you have Argo CD operator. right? Then you have min IO operator. So these are the different operators. The reason why I'm stating them here is you can look into these repositories. They are all available on GitHub, and you can gain your understanding on operators. Like if you want to get more insights on the Kubernetes operators, you can go to these GitHub pages. I'll also try to put these things in the description, and you can read about these operators, like how they are written, what are the issues on these operators. If possible, you can also contribute to those operators. So that's why I explained what are the popular operators. And most of these operators are written in a popular framework called Operator SDK. Okay, so Operator SDK is a framework that you have to use if you are writing a Kubernetes operator. So let me tell you something here. Back when I started writing the Kubernetes controllers or Kubernetes operators, I think it is before 5 years when I initially started contributing to Kubernetes controllers. At that time, you have to do a lot of things by your own. For example, you have to set up your own watchers for Kubernetes. You have to set up your own listers for your Kubernetes clusters. Sorry, for your resources, where your, let's say you have a Kubernetes controller and it has to watch for your custom resource. So in such cases, you have to create your own watchers. You have to interact with client Go by yourself. You have to maintain a queue. But right now, this situation has gotten much better. For example, if you want to write Kubernetes controllers, there is a popular framework called Controller Manager, which does a lot of things for you. Similarly, if you want to write a Kubernetes operator, then there is a framework called Operator SDK, which we will cover today. So again, Operator SDK does a lot of things for you. So this way, right now, it is much easier to write a Kubernetes controller or a Kubernetes operator. Of course, you need knowledge and you need understanding of writing applications using Go language, because most of these operators are written in Go language. And end of the day, these frameworks, whether it's Controller Manager or Operator SDK, they provide you some bootstrapping code. Okay, what is bootstrapping code? Basically, they provide you steps to interact with uh, client Go. They create watchers automatically. Okay, they maintain the queue automatically when there are multiple custom resources that are created. Previously, like I told you, we had to create all of these things by our own. So right now, the interaction with client Go, okay, what has got automated? The interaction with client Go, whatever you have to deal with the client Go, whether it's creating watchers, whether it is creating listers, whether it is creating the queue, the FIFO queue inside when you want to handle multiple Kubernetes clusters and multiple Kubernetes custom resources and interact with Kubernetes client Go. All of these things is automated using the frameworks like Operator SDK and Controller Manager. But after this, like I told you, the key thing for Kubernetes operator is the reconciliation logic. Okay, the reconciliation logic is to create the resources, whatever the resources that I have mentioned, and to auto heal the resources whenever something is going wrong, right? This is the primary responsibility that you have to handle when you are writing a Kubernetes operator, right? So if I'm writing Istio based Kubernetes operator, in the Kubernetes operator, because all of these things are automated by my framework, the thing that I have to handle inside is the reconciliation logic. And inside the reconciliation logic, what I'll do is I will handle the creation and auto healing of my Kubernetes resources. Of course, you also have to handle the deletion. So when someone deletes the custom resource for the controller, then using the operator, using the reconciliation logic, you have to also delete the resources that are created. So this is the end goal, that you have to write the reconciliation logic in Go language. Then the other thing that you have to understand is, okay, you have explained about everything, Abhishek, like the operator, how does it work, what is the reconciliation logic and all. But once I create the operator, where do I store this operator? Again, I'm going to show you this live as well, but to make you understand, there is something called as operatorhub.io. Similar to Docker Hub, where you store all of your Docker images, operatorhub.io is a place where you have all of your Kubernetes operators. Of course, unlike Docker Hub, operatorhub.io only hosts the approved operators. That means right now, if you create your own operator, you cannot put that operator bundle inside the operator hub.io unless the maintainers of operator hub.io approves your operator. And this is very good because you know which are the authentic operators, which are the operators that are actually in the working state. Right now, you can go to Docker Hub and you can download any Docker image, but you don't know if it works or not. Probably you can look at the stars, you can look at number of people using it, but you never know if that Docker image is working or not, and all the other complexities with it. But if there is an operator in operator hub.io, then that means to say you will be able to install that operator, you will be able to handle the upgrades using that operator, and that operator is working. Okay, or that operator is verified. Okay, so operator hub.io is a place where you get all of these things. Now, once you download the operator, let's say, okay, I got it from operator hub.io. Now, how do I install it? So let's say you have a Kubernetes cluster. Okay, inside the Kubernetes cluster, what you will do is you will install a software, or you will install a package called OLM. OLM is Operator Lifecycle Manager. So once you install the OLM, OLM is the one that will look for the operator bundle that you have downloaded or the operator that you have installed. Okay, and OLM will approve, OLM will verify the operator one more time. Once you download it from the operator hub.io, if all the things that you have provided are correct or not, and then it would create the operator related resources. Okay, what is operator related resources? Whatever that you have built in the Go language. Like for your operator, you must have created some deployment in the Go language, right? So this deployment is created using the operator lifecycle manager. So this is end to end about your operators. Now let's try to understand this practically. Like till now I showed you, I mean, I just explained the theory part of it, how this works and all. Now I'll explain you practically. I'll start sharing my screen and I'll show you where, I mean, I'll talk about this operator hub.io, the documentation for how do you refer to the documentation, what is the architecture. Like I have drawn an architecture, so I can also show you the architecture of how this entire thing works. And finally, we'll open a Visual Studio Code and we'll also try to create an operator. Like I'll show you how to create step-by-step approach of creating the operator. And yeah, that way we'll conclude the video. So I hope the things are clear till this point of time. If something is not clear and if you want to ask questions to me, then please provide the timestamp of the particular thing that you have not understood, so that I can quickly reply depending upon your question. Okay. Yeah, one thing I forgot to mention is you can install the operators even without operator lifecycle manager. You don't need operator lifecycle manager to install the operators, but it's a preferred way of installing the operators. Now, to start with the practical journey, the first thing that you have to do is go for this website called, go to this website called Operator Framework. So just search for Operator Framework, and this is the first thing that you'll see. Welcome to Operator Framework. Just move here and you get the entire information, like whatever even we discussed. You can understand what is an operator, why you require an operator, best practices, and going down you will also read about OLM, and everything is available here. Let's say you want to understand more after watching my video, this will be your point of reference. So just jump into this portal called Operator Framework and you'll get everything about operators. So what we are interested right now is to go through the documentation. Okay, now what is our end goal? We go to the SDK documentation, which is a framework to build the operators, and we will try to write an operator. But if you want to write an operator, you need to have a controller, right? So for which controller are you willing to write the operator? That is the first thing that you have to decide. So to decide that, what you will do is you have to go to this website called operatorhub.io. Okay, so in operatorhub.io, like I mentioned, all the authorized or all the approved operators are here. Okay, who are approving this? So if you go to github.com and there is a GitHub repository called community operators. So whenever you want to create your own operator, okay, once you build your operator and everything, you have to put the proposal to the community operators. Okay, so if you see the pull request, like whenever you create a new version of your operator, or whenever you want to submit a new operator proposal, you have to submit to this portal called community operators. You have to follow the contribution guidelines and everything, and once it is approved and once it is merged, then your operator will reflect in the operator hub.io. Now, if you want to write a new Kubernetes operator, the first thing that you have to do is to look for the projects that do not have operator. For example, if you search for Istio here, okay, so Istio already has an operator. Okay, let's say you want to write an operator for Prometheus. Okay, so I know that Prometheus already has an operator, but for someone who are trying to write an operator, firstly they have to search for it, and you can search for Grafana. Grafana already has an operator. So even if you write the operator, your proposal or your pull request will not be merged here in the community operators, because the operator is already available. So to get or to write a new operator, firstly you have to choose the controller. I can give you some suggestions here because I decided to make this video. I was exploring the different Kubernetes controllers which are popular, yet they don't have the Kubernetes operators. So one such thing is Kyverno. So Kyverno does not have a Kubernetes operator. So you can write a Kubernetes operator for Kyverno. And we did a video on KubeShark. KubeShark also does not have a Kubernetes operator. And we did a video on, for example, we made a video on Crossplane. So Crossplane has an operator, but this is a wrapper of Crossplane. So you can still go ahead. I mean, Upbound has created a Crossplane operator, but still it's a wrapper on top of Crossplane. So you can also create a Crossplane operator. So these are some of the things where you can write your own operators. So you can choose any of these examples. And for the purpose of video, because I have to explain you people. So what I'll do is, let's take example of KubeShark, because I know KubeShark is one single controller, and basically I looked into the code for KubeShark, and I felt if someone is willing to write an operator, then KubeShark is definitely a good project. I'll tell you why. So if you go to GitHub KubeShark, so always choose the projects where your contributions, like for example, you have only 5 or 6 repositories here, and there is only one single controller. So to write the Kubernetes operator, this is the best project to start with. If you're choosing projects like Argo CD or Istio, where they have 5 to 6 controllers in the project, so if you write an operator, you have to accommodate all of those 5 to 6 controllers in a single operator. So with that, the problem would be your operator becomes very huge, and your reconciliation logic will also become very huge, because you have to manage some 50 to 20 resources. I mean, 15-20 resources. Whereas if you choose projects which have very less resources, then your operator reconciliation logic will be very less. So you can start with some simple projects. So KubeShark is one such project, and I can recommend this one, or you can also go with Kyverno. So even in Kyverno, you don't have to write a lot of reconciliation logic. So if you want to use this one, the first thing that you have to do is follow the documentation, again go back and choose what type of operator do you want to build. Do you want to build a Go based operator, Ansible based operator, or a Helm based operator? Personally, I would recommend Go based operator. The reason for that is, if you are choosing Ansible or Helm based operator, then you will not create a full-fledged operator. Okay, like I mentioned in the theory part, Ansible and Helm based operators are level 1, level 2 operators, whereas with Go, you can go till level 5, and you can support features like telemetry, backup recovery. You can create features like autopilot. Everything can be created only with the Go based operators. And you can, if you go here, build an operator, you can get all the differences here. What is the difference between Ansible based operator, Helm based operator, Go based operator? Like I told you, this website is your point of reference, but it will be too lengthy if I start discussing about all of those things. So go with the develop with Go, and here you need to start with the prerequisites. Like I told you, this will create a lot of bootstrapping. You can also create operator without this framework, but in that case, you have to write your own logic interacting with client Go. You have to write your own logic for handling the FIFO queue to submit the request to client Go. Let's say to your operator, there are 100 requests that are sent. Okay, so there is one operator and 100 projects wants to create, for example, KubeShark. You created a KubeShark operator and 100 projects in your Kubernetes cluster, 100 namespaces, they are in different namespaces, and they want the KubeShark controller. So they will start submitting requests to you, and you have to keep this 100 requests in a FIFO queue, and you have to send that request to client Go. But to write all of this logic by yourself, it takes a lot of effort, and you have to also create watchers to ensure what is the differences, what is changing. To avoid all of those things, use the operator SDK framework so that this effort is eliminated. Now, the very first thing that you have to do is go with the prerequisite section. So in the prerequisite section, you will notice that to write Go based operator, of course, you will need Go. But apart from that, you need to have Git installed, you need to have Docker installed, and you need to have kubectl installed. Okay, so personally on my machine, I have all of them installed. Okay, so if you just search for it, let's say Git version, I already have Git installed. Then I already have Golang. I have the latest version of Golang installed. So I have all the prerequisites done. And I've also created a folder called KubeShark where I'm going to create this operator. Okay, so perfect. Now let's go back because my prerequisites are meeting. Then it says you need to have cluster admin privileges to your cluster. I already have the cluster admin privilege. So I mean, I'm ready with this step as well. And then you need to have access to Docker Hub or Quay.io, which is fine. I think most of you have access to Docker Hub, so don't have to bother about it. Then create a folder. So throughout this documentation, operator SDK will explain you how to create an operator for memcached operator, which is just like a dummy operator. But in our case, we want to create for KubeShark, right? So that's why I created a folder called KubeShark. And then cd to the folder. Then this is the command which is very important. I'll explain you what is this doing. And when you see this, you will realize what amount of bootstrapping is done here. So once I execute the command, I'll take my Visual Studio Code and I'll show you what are the folders that are created. So operator SDK init, firstly start with this one. You need to have a GitHub repository because end of the day, you'll push the GitHub, this entire code to the GitHub repository, right? So what I'll do is, let's say my GitHub repository that I would create. Right now, I'm not creating it, but I'm just showing it for the purpose of demo, and I'll call it KubeShark operator. Okay, and then choose a domain. If you don't want to choose a domain, you can keep it empty. Okay, there is no problem. So as you click on enter here, you will notice that a Go project is created for you. Operator SDK has initialized a Go project. If you do ls-ltr, or we can also take Visual Studio Code. If you feel Visual Studio Code is much better, I can take the Visual Studio Code and I can show you from there. Just give me a minute. Like, yeah, I would definitely prefer VS Code, but the only thing is, so just import the folder. You can open the new folder here in the Visual Studio Code. It's created in my Go workspace. So this is the project, right? KubeShark. And notice that the operator SDK has initialized a lot of things for you. Now, what did it initialize? It created the entire Go project for you, the Go modules, and look at the modules that it has created for you. Like all of these modules are imported. If you notice that these modules are some of these modules, like for example, controller runtime, right? So this controller runtime is responsible, like I told you, this is a framework that is used to write your Kubernetes controllers. Okay, so if you are willing to write a Kubernetes controller, then you have to use the controller runtime package, because using this package, you can reduce your effort significantly, because this will take care of bootstrapping a lot of code for you. Even the operator SDK internally uses the controller runtime. And then if you move to the config folder, then it has created a lot of things for you. These are the manifests. These are some of the things that are used by the operator to install the operator, and the OLM related configuration, everything is available. Now, once this is done, like the operator init command has created for this, the next step is really important, where you create the next significant things. That is, you create the API for your operator. Okay, so what is the API? What are we creating? Basically, if I copy the command here and if I show you, so what we are doing here is operator SDK, create API, group, version, kind, and resource. So for everything in Kubernetes, for every resource that you are creating in Kubernetes, you need to have a API group, you need to have kind, and you need to have version, right? So even for the operator, like operator is nothing but it's kind of a deployment, right? Now this operator creates resources for you, the controller for you, like we are building a Kubeshark operator. Now Kubeshark operator has to create a Kubeshark controller, but to create it, you have to submit a custom resource to it. Now, what is the custom resource that you want to users to submit for you? If there are 100 people who want to install Kubeshark controller, okay, they have to interact with the Kubeshark operator. Only then they will be able to create 100 Kubeshark controllers. So you need to define that custom resource. Right now, to define that custom resource, what I will do is I will say the kind. You can choose anything here. I'll just call it as a Kubeshark operator. Okay. And then what I will do is version. Let me keep it as V1 Alpha 1. I don't mind having the version as V1 Alpha 1 because this is just a alpha project right now. And then what should be the group? So to decide the group, keep the group as relevant as possible to your group, to your project. So what you can do is go to the CRDs. I haven't explored the code of Kubeshark, but I know that there will be CRDs somewhere. So you can go to the CRD. So it should be somewhere in the config folder. Uh, if you go here, okay, no problem. You can define your own CRDs as well. Probably you can call it as kubeshark.example.io. You can define any CRD, or you can define any group for it. So later point of time, if you want to change, you can also change it using the same command. Now, once you create the API here, now you will notice that it will create a lot of additional things for you. And this is where the operator will create all the required watchers. Operator will create all the required code that will interact with the client Go for you. Okay, now this step is really important because once I go back to Visual Studio now, see here, the next step is the only step that you have to do is you have to, implement your new API and generate the manifest. So if you go back here, now the API folder is created. Previously, there was no API folder. Right now you have the API folder, and see, these are the things that are created for you. So Kubeshark operator types.go, it has created the version.go, depending upon the version information that you have provided, kubeshark.example.io. I said this is my custom resource, and everything related information is created. Now, all that I need to do is I have to define my custom resource definition, and then I have to write the reconciliation logic. So to do that, what you need to do is you need to have some experience with the operators. Okay. So right now I showed you how to create how to create this API group and how to do this. Now what you will do is go to one example project, and I've created an example project. Okay. So just come here, called github.com. I'm Veeramalla. Argo rollouts operator. So I'm writing a operator for Argo rollouts. So what you can do is you can see what are the different things that are created. You can go through the commits and you can explore each and every commit that I've been creating. But apart from that, what you will notice is how do you define the custom resource? Okay, so for that you need to have good idea of the project that you are working on. Right now, this is the Kubeshark project. So what you need to do, you have to go and explore the Kubeshark project. Once you explore the Kubeshark project, you will start understanding what are the fields that are required for your custom resource. Okay, now let me just go here and explain this for you. Okay, so if you go to any website for clear understanding, so basically right now you are writing an operator. Okay, let's say this is your operator that you are writing. And what is your end goal through the operator? Your end goal through the operator is to create a controller, right? You want to manage this controller using the operator, but there may be 100 other controllers that are required, right? This is not just the only controller. there might be 100 other projects in your Kubernetes cluster, and you want to create like namespace scoped controllers, or you just want to create one controller, that is also fine. But how will operator know that you are looking for a controller? You just install the operator, but operator needs a trigger, okay, and using the trigger it can create the controller for you like any other Kubernetes resource, right? So what is the trigger? The trigger would be a custom resource. So a user once installs your operator, what a user would do is user would submit a custom resource to the operator, and operator reads the custom resource, and then operator creates the controller for you. Okay, now as part of the Go code, what you need to do is you need to define this custom resource. Okay, so how do you define this custom resource? One thing is you can keep it as simple as possible. For now, if you want to create the operator for Cube Shark project, what you need to do is understand what are the different resources that this controller has to create. For example, in CubeShark, what are the resources that are required? Do you need CubeShark deployment? Do you need CubeShark related config maps? What is CubeShark creating when you are installing it manually? So keep a note of all of these resources, and using the CRD, you will try to populate what are these required resources. You can also keep this custom resource spec empty. Okay, so that right now, because you are a beginner, what you can do is in the CubeShark types.go, this is the one that is created already by the operator, and the spec is empty. You can leave this spec empty, just delete everything that is provided here and keep the spec empty. Later point of time, once you become expert with it, you can provide the spec. But for now, keep the spec empty and tell the operator that whenever someone submits the custom resource, even with the empty spec, with no spec, nothing in the specification, create the controller, all the required resources of the controller. Okay, now where do you write this specific code? Go to the controller section, and it has created something called CubeShark operator underscore controller.go. Okay, so here you start writing your controller related logic. This is the Go language based logic that you will start writing, and here you will write the reconciliation logic. Okay, so to understand how to write the reconciliation logic, everything is bootstrapped. Only thing that is left is how to write the reconciliation logic, and for that you have to refer the operators. For example, you can take example of my operator that I'm writing for Argo rollouts. So go here and see, these are the resources that are available for Argo rollouts. One is deployment.go, and if you go to the resources, there are multiple resources that I'm reconciling. One is role, then I'm reconciling role binding, then I'm reconciling config maps, right? Then I'm reconciling the rollout service, and in the deployment.go file, I'm reconciling the deployments. So this repo is up for your example. You can refer to this repository and create your own operator for CubeShark or any other controller. So the reconciliation logic is not that difficult. Once you see one example, you will understand what am I doing. Even there are some examples provided in the operator SDK framework, but because I've added some test as well, you can refer to the code and you refer to the test, and you can start writing the reconciliation logic. In your case, it will be much easier than my operator, because for CubeShark, there is only one deployment, and you can only handle the reconciliation for deployment as you start with. Okay, so you can just take example of this file in my repo called deployment.go, and you can read through it. And if there are any questions, you can put in the comment section, or probably if you understand everything else, then you can ask me specific questions with respect to the reconciliation, and I can also make a video on top of that. So this is the video for today. I know it's a bit lengthy, because I wanted to cover everything related to the operator in one video. That's why I took a little long time. But yeah, in future I'll do more videos where, if everyone in the community is interested towards the operators, I'll focus more and explain the reconciliation logic as well. But it's not that difficult. Okay, thank you so much. I hope you enjoyed the video that I made today, and I'll be making more such interesting videos in the future. Thank you so much for watching. Please subscribe to my channel. Take care, everyone. Bye.